This is going to be a short video on verifying solutions to differential equations. In class, we've already talked about how to solve differential equations by separating the variables, finding the integral on both sides, and solving for c or solving for y. In this video, we want to take a look at a differential equation, and we want to see if we can find the solutions without necessarily solving the differential equation. So, I have two examples here. The directions tell us to decide which, if any, of the following functions are solutions to the differential equations. So, let's take a look at what we have here, kind of analyze the situation. Here's our differential equation. Remember, a differential equation is simply an equation involving a derivative, and so there's our derivative of y prime. And it's basically a multiple choice problem. We want to know, is this a solution? Is this the original equation? Is this? Is this? There could be more than one answer depending on how the equations are written, and we'll take a look at that also. Now, one way to solve this differential equation would be to separate the variables. So we have y prime, or let's rewrite this as dy dx, is equal to negative 2y. We can separate just like we always have. So I'm going to divide both sides by y, and I have 1 over y dy. I'm going to multiply the dx to the other side and have negative 2 dx, and then we can find the antiderivative on both sides, and we can solve for y and find our solution. That's not the only way to verify the solution, so I'm going to show you one way. Okay, so method number one is to actually solve the differential equation and choose your solution. The other way that we can do that is, let me get rid of what I just wrote here, is to kind of work backwards and look at the solutions. What this differential equation is saying is, when you take the first derivative of your function and you add it to 2 times the original function, you should get 0. So we're going to test out these functions to see if they meet the criteria. So the first thing it tells me I need to figure out, well, I have my original function right here. My original function is x squared. So I'm going to find the first derivative. So y prime is equal to 2x, and the original function is x squared. So here's the test over here. It says take your original function, which, it says take your first derivative, which is 2x. It says multiply 2 times the original function, so plus 2 times x squared, and see if you get 0. Well, 2x plus x squared, 2x squared, is not equal to 0. So this is not the solution to that differential equation. All right, in part B, I'm going to do the same thing. I'm going to take the first derivative. This is my original function. I'm going to take the first derivative. Y prime is equal to 2 e to the x. So I'm going to come back over here, and it tells me to take the first derivative. So the first derivative is 2 e to the x. It tells me to add it to twice the original, plus 2 times 2e to the x. See if that's equal to 0. So I get 2e to the x plus 4e to the x, which is not equal to 0. So this is not a solution to the differential equation. All right, let's try that one more time. I'm going to take my original equation. I'm going to find the first derivative. So I get y prime is equal to e to the negative 2x times negative 2, that by the chain rule. I'm going to come back over here to the differential equation. I'm just trying to see if this equation meets the criteria. So it says take the first derivative, which is negative 2 e to the negative 2x, right there. Add it to twice the original, so 2 times e to the negative 2x, and see if that's equal to 0. So I get negative 2e to the negative 2x plus 2e to the negative 2x, and guess what? That's equal to 0. So this is a solution to the differential equation. To the differential equation that we have over here. So that's another way to find the solution to the differential equation without actually solving the differential equation. So 2 ways. Actually solve the differential equation and choose your solution, or see if the equations meet the criteria, or see if the functions given meet the criteria of the differential equation. All right, let's take a look at another example. Make sure you got it. You might even want to try this one without looking at the video and then resume the video. So first of all, let's analyze our differential equation. Now notice this one says you have to take the second derivative of the original function minus the original, and you're trying to equal 0. And they don't necessarily always equal, the equations don't have to equal 0, they just happen to in this case. So this is my test. This is the equation I'm trying to satisfy. Now notice this time I have to find not just the first derivative, but also the second derivative. So y prime, first derivative, derivative of sine is cosine. And I only needed that to get to the second derivative. The second derivative, the derivative of cosine is negative sine x. Now I'm going to kind of lightly cross that out because the only reason I needed the first derivative was to get to the second derivative. All right, I'm going to come back up here to my equation, which says take the second derivative and subtract the original. So the second derivative in this case is negative sine x. It said subtract the original sine x. Is that equal to 0? Well, negative sine x minus sine x is negative 2 sine x, which is not equal to 0. This is not a solution to the differential equation. All right, let's go again. The first derivative of the second function, so y prime, first derivative, is 4e to the negative x times negative 1. There's your chain rule. The second derivative is equal to negative 4e to the negative x times negative 1. So that's positive 4e to the negative x. Don't need that anymore. I'm going to go back over to my original equation, which says take the second derivative and subtract the original. So the second derivative is 4e to the negative x minus 4e to the negative x. That is equal to 0. So this is a solution to the differential equation. All right, let's check out the last one. You'll note if you look at the two equations, these are in the same format or a very similar format. So it may be that both of these are solutions to this differential equation. Let's find out. We need to find the first derivative of this exponential function. So we get ce to the x. We need to find the second derivative, which is ce to the x. Don't need the first derivative anymore. I'm going to run the test, which says take the second derivative, which in this case is ce to the x, subtract the original, which is ce to the x, and you do get 0. So this is also a solution to the differential equation without actually solving the differential equation. And notice, we haven't done solved any differential equations where we had the second derivative. So in this case, you couldn't solve the differential equation based on what you know so far. You would actually have to use the equation to test out which of these are the solutions. So if you are in my class, you, for homework tonight, are going to do the following problems. You are looking at page 440, 1, 2, 3, 7, 15, 18, 21. And on problem number 15, just solve the equation. So watch this video as need be. Get that homework done.